All right, guys, in this video, I'm going to go over some of the converse theorems. So again, thinking about that word converse from our work with conditional statements, they're just going to trade positions from when we did this in the last section. So like in the last section with corresponding angles, the actual just corresponding angles theorem, we said if two lines are parallel, then corresponding angles are congruent. So we're just going to switch that and say if two angles, let's get two corresponding angles are congruent, then the lines are parallel. All right, so as I mentioned earlier, we're just trading the position side, thinking about if P then Q, now is if Q then P. All right, so that's what that converse means. Alternate interior angles converse theorem. So similar to the one we just did, if two alternate interior angles are congruent, then the lines are parallel. Okay, let's keep going. You'll sense a theme here. Alternate exterior angles converse theorem. If two alternate exterior angles are congruent, then the lines are parallel. All right, this last one is a little bit different. Remember, this is that one with consecutive interior angles, so same side interior angles. This is where they're not congruent, they're supplementary. So we're going to say if two consecutive interior angles are supplementary, then the lines are parallel. Okay? Now, this is exciting because after we do a little bit more work with the notes here and an example, we're going to get into our first proofs together, where we're going to be using these theorems from the last unit, so 3.2, so like the corresponding angles theorem or the alternate interior angles theorem. So the ones that we did last lesson, where we're saying if the lines are parallel, then this is true about these angles. And we're also going to use these theorems where they essentially like trade spots, right? If the sentences about the angles are true, then we can prove the lines are parallel. All right, so we'll just, based on what we're trying to prove, we can use the original or the converse. Okay, now one more kind of property you need to know about before we kind of move on is the transitive property of parallel lines. All right, you guys probably already know the transitive property from your days in middle school, but if you don't, the idea with the transitive property, if A equals B and B equals C, then A is equal to C. All right, that's the transitive property you would have heard of. So in this case, if we have two lines are parallel to the same line, then they are parallel to each other. So if you have line P is parallel to line Q and line Q is parallel to line R, then based on this transitive property, line P must be parallel to line R. Okay, we'll be talking about that very soon. All right, so the first example that I want to go over is how we can find the value for X in this figure to prove that A is parallel to B. So basically, what would X need to be to allow us to use one of these theorems that we just mentioned? All right, so if you notice these angles, right, these are corresponding angles. So essentially, I can use the corresponding angles converse theorem. If I figure out a way to make these two angles congruent, then I could say that line A is parallel to line B. All right, so I'm going to set 74 equal to 9x plus 11. I'm going to move that 11 to the other side to get 9x is equal to 63, and dividing both sides by 9, I'll get x equals 7. So if x equals 7, then we can use the corresponding, right here at the bottom, the corresponding angles converse theorem to prove that line A is parallel to line B. All right, but x has to be 7 for that to work. Okay, let's do a proof here. All right, so remember, think back to the proofs we did with the algebraic proofs, like solving an algebraic equation. We're gonna do a lot of practice with this where, I'm gonna try to give you a lot of help in terms of the statements in this one, and I actually have the reasons below the table there in that reasons bank. All right, we've talked a little bit about some of these, but again, we're gonna go slowly, and again, this is very tricky, but I'll do my best to help you kind of logically see the path here. So we wanna prove that line G is parallel to line H, and they're telling us that angle 4 is congruent to angle 5. That is the given. So I'm gonna go ahead and use my first reason is always going to be given. All right, so that one's already been used. Now, the next statement says angle 1 is congruent to angle 4. So if I look at that, that's angle 1, angle 1 to angle 4. And hopefully we know this from the first unit. Those are vertical angles, which means they are congruent. So I'm going to use the vertical angles congruence theorem. All right, so that is saying that angle 1 is congruent to angle 4. Now, I kind of mentioned this in the notes section about parallel lines, but in this case, if you notice, the first statement says angle 4 is congruent to angle 5, angle 1 is congruent to angle 4. So after that, we can actually say that angle 1 is congruent to angle 5. That is called the transitive property, which I have in my bank of angle congruence, right? The idea of A is equal to B, B is equal to C, so then A must also be equal to C. All right, so that transitive property of angle congruence goes next. And last but not least, if angle 1, I'll highlight again, I'll use pink. If angle 1 and angle 5 are now congruent, like we just mentioned in that previous line, we can use the fact that those are congruent and corresponding to use the corresponding angles converse theorem, which we just talked about above, which allows us to state that if those two angles are congruent, then lines G and line H must be parallel. All right, so this is going to be the corresponding angles converse theorem, which proves that they are parallel. Okay, so that's how these proofs are going to work. We're going to do one more together, and then I have some for you to practice, which you can check out the key on Canvas, and then also there'll be homework where you're practicing this as well. Okay, let's do example 3. All right, to make this a little more challenging, I didn't put any of the statements, but again, you'll notice to kind of help you, the given is always going to go in the first statement slot, and the proof is going to go in the last one. So in this case, since there's only 3 rows here, I didn't think it was that big a deal to fill it in ourselves. So let's do the given. Angle 1 is congruent to angle 2, so that is our given. All right, again, we're trying to prove that angle 3 is congruent to angle 4. All right, so now we need to figure out what goes in the next step. So we have angle 1 is congruent to angle 2. Notice how those are alternate interior angles. So because we know that those are congruent, we can actually use the alternate interior angles converse theorem to state that line K and line J are parallel to each other. So I'm going to go ahead and say that K is parallel to J with the alternate interior angles converse theorem. All right, which is down here. And then once I know that those are parallel, if you look at angles 3 and 4, you should notice that angle 3 and angle 4 are corresponding. So this is actually a theorem we used in the last lesson, 3.2, that states if you have 2 parallel lines cut by a transversal, then corresponding angles are congruent. So angle 3 is congruent to angle 4 because of that theorem, the corresponding angles theorem. So I think it'll just take a little time for your brain to know, which way are we going here? Are we going the way we did in the last lesson, where we're told or we know that the lines are parallel, so we're going to prove or say something about the angle congruency, or do we know something about the angles being congruent, and because of that, we're now going to prove that lines are parallel. So again, the idea is, we just got to know which way we're going to help us know if it's the original statement or theorem or if it's the converse. All right, so don't forget to practice a couple. I've got some on here to try, and then there is some homework as well. All right, come see me if you have any questions. Good luck.